Hello, good day everyone. I'll start by introducing myself. I am MARTHONY ALOB, and I will be one of the reporters for our group. By the way, we are Group 6, and we'll be tackling on soil pollution. Soil is one of Earth's most essential natural resources. It supports plant growth, provides habitats, and plays a key role in our food production. However, soil pollution is now becoming a serious threat to ecosystems and human health. That's why today we'll be digging down to the very bedrock of soil pollution to understand its causes, impacts, and what we can do to protect our land. So before we begin, here's our agenda for today's presentation. Firstly, we have soil composition and layers. Then we have the types and sources of land pollutants. And then we have the effects to human health, vegetation, and environment in general. Then next we have application of waste management hierarchy. So lastly, we have the control techniques of land pollution. So let's begin with soil compositions and layers. Soil is composed of minerals and organic matter. It contains air, water, and microorganisms. Because of this unique composition, it serves as a medium for plant growth, a home for animals, and a reservoir for water. Within the soil, numerous processes take place, including the nutrient recycling, water purification, and gas exchange with the atmosphere. Together, all of these functions highlight why soil is essential for sustaining life on Earth. Now that we understand how vital soil is, it's also important to look at what soil is actually made of. And although it varies by location, a typical soil is composed of about 45% minerals, 25% water, 25% air, and around 5% organic matter. Mineral matter, these are derived from weathered rocks and contains these nutrients like potassium, calcium, and magnesium. And then air, which provides oxygen for roots and microorganisms that need air. And of course, water, which are held in the soil pores, are also essential for plant growth. And the organic matter, of course, is from the decomposed plants and animals that remain in the soil material. So now let's talk about soil texture. Soil texture refers to the relative amounts of sand, silt, and clay in the soil. These three components determine how soil feels, behaves, and supports plant growth. So here we have sand. It is the largest particles. It has the largest particles, and it feels gritty and has large spaces between particles, so water drains quickly. However, it doesn't hold nutrients very well. So next, we have the silt particles, which are medium-sized. They feel smooth or flour-like when dry, and silt holds water better than sand and provides good nutrient availability, making it important for fertile soils. And lastly, we have the clay. It has the smallest particles, and it feels sticky when wet and hard when dry. Because these particles are tightly packed, clay holds water and nutrients very well, but sometimes too well, which can restrict drainage and root growth. And so, here, to classify soil texture, we use the soil texture triangle, a ternary diagram that shows how different percentages of sand, silt, and clay combine to form textures such as sandy loam, silty clay, or pure clay. As I show you this triangle, notice how each region corresponds to a specific mix of these three components. And so, overall, soil texture affects water retention, aeration, nutrient supply, and how easily roots can grow, making it a key factor in soil health and agriculture. So, after learning how soil texture affects plant growth and water movement, it's also important to recognize that soil isn't the same all the way down. It forms distinct layers over time, each with different properties and functions. These are called soil horizons, and together they make up the soil profile. So, let's start with the O horizon. The O horizon is the organic layer, full of decomposed leaves, twigs, and other plant matter. This is where nutrients start their journey into the soil. And below that is the A horizon, or topsoil, the most fertile layer. It contains a mix of minerals and organic material and is where most plants' roots grow, making it essential for agriculture and vegetation. Next comes the E horizon, also known as the leaching or eluviation layer. Water moving through the soil washes minerals downward to this zone, and those minerals often end up in the next part, the B horizon or subsoil. It's denser and has more clay and mineral deposits like iron and aluminum, which accumulate over time. And going deeper, the C horizon contains partially broken down parent material, pieces of rocks that are slowly weathering into soil. There is very little living activity here. And finally, at the bottom is the R horizon, which is solid bedrock, the original rock layer that forms the base of the entire soil profile. So, together, these horizons show how soil forms gradually from rock and organic matter, creating the foundation for life above ground. And with that, we have seen how soil is structured and what makes it capable of supporting life. Now, to better understand the challenges our soil faces today, Ms. Tantuico will be discussing the types and sources of land pollutants that threaten soil health.
Thank you, Mr. ALOB. Now let's move on to the next subtopic, which is the types and sources of land pollutants. It is evident that the land that we tread is extremely sensitive to our actions. We see the consequences, the damage with our own eyes. In order to combat the problem, we have to get to know them first. Here are the types of pollutants, starting with solid waste, discarded or unusable solid materials that are no longer needed. They pile up and take a long time to decompose. So, solid waste don't just disappear when we discard them or throw them away. They accumulate as litter, end up in landfills, and even last for decades. These wastes were once objects each one of us has used. So an example would be plastics, glass bottles, paper, metals, rubber, and even packaging materials. So now, beyond the visible litter, we also have chemicals or chemical contaminants. Toxic substances from industrial, agricultural, or household activities that can poison the soil. So toxic means poisonous, looming from industrial, agricultural, and even household activities. These toxins don't only kill plants but seep into the ground, contaminating our groundwater, which creates a chain reaction and damaging even as much as our food chains. So an example, we have industrial solvents, cleaning agents, heavy metals, and oil spills. So these substances aren't rare or exotic. They come from daily household items that we often overlook, unknowingly causing great consequences. Now, next we have a specific version of chemical pollutants affecting our land. Pesticides and fertilizers. Substances used in farming to kill pests and promote plant growth. but when used excessively, they contaminate the soil and nearby water. So these are all used in good intention. They help grow our food, but in paradox, when used excessively, can contaminate our soils. These build up in the earth and can even be washed away by the rain and eventually end up in our water sources. Examples would be insecticides, herbicides, nitrogen, and phosphate fertilizers. Lastly, we have deforestation, the removal of trees and vegetation, which leads to soil erosion, loss of nutrients, and land degradation. So unlike the others which added, this one is the act of taking away a protective layer. It is important to note that these trees' roots hold the soil like a protective blanket, keeping it from erosion, exposure, and degradation. When soil erodes, it makes for a weak topsoil. So, when easily washed by rain and wind, there would be loss of nutrients, which makes the soil barren, especially the important fertile layer. Land degradation talks about the loss of the land's ability to support life itself. So, an example of deforestation, we have logging activities, clearing forests for agriculture, or even urban expansion. So as we can see, economic and social systems drive deforestation, but at what cost? Now that we've talked about chemicals and processes of deforestation, let's now talk about how and which these pollutants enter our environment. So, sources of land pollutants. Firstly, we have municipal waste. It refers to everyday trash from homes, businesses, and institutions that is collected by a local government's waste management system. So this would be our everyday trash. And the problems lie from the volume of waste that we generate at home, work, and school, which contain materials that damage our surroundings. On a larger scale, we have the industrial waste. It is any material discarded from industrial processes such as manufacturing, mining, and power generation. It can be solid, liquid, or gas and can be either non-hazardous or hazardous. If not properly managed, it can cause serious health and environmental damage. So these are materials or byproducts from manufacturing, mining, and our power plants, which cause a variety of waste type and calls for a thorough regulation and responsible disposal. So next we have sewage and water systems. It is waste from domestic, commercial, or industrial sources, often containing human waste, and its pollution of land can lead to soil contamination, groundwater pollution, and even damage our ecosystems. These are the unseen waste when improperly treated, contaminate soil with harmful pathogens and chemicals. These also cause threats to the water sources and even damage our ecosystems. Now we have the fastest growing waste in the world, which is the electronic waste. It is discarded electrical or electronic equipment that contains toxic substances like lead and mercury, which cause significant land pollution by leaching into the soil. So not only do these serve as solid waste, but they contain toxic substances that when dumped in landfills, they may leach into the soil and poison it long term. These wastes show a direct pollution caused by our very lifestyle. So next, we have construction debris. It is waste generated from the construction, renovation, or demolition of buildings, roads, and other infrastructure. It can cause soil and water contamination from heavy metals and other pollutants, loss of fertile land, habitat destruction, and greenhouse gas emissions from overflowing landfills. So, these debris may cause not only a degradation of land, it can also cause destruction in our very ecosystems. Next, we have mining activities. It refers to the leftover materials like overburden, waste, rock, and tailings, which can cause land pollution through contamination, erosion, and habitat destruction. So like the other waste, mining activities destroys habitats and leaves dangerous chemicals that may destroy ecosystems. Now we have our two crucial sectors in our community that contribute to land pollution. First, we have agriculture and farming activities. It is refuse from farming and animal husbandry, including crop residues like stalks, leaves, and animal byproducts like manure. It also includes materials from farming operations such as chemical containers and waste oil. So, everything from crop residues to animal byproducts, though natural in origin, can be produced in massive amounts in this industry. Pesticides will also create a double burden as another chemical waste in this source of land pollution. Next, we have hospital and healthcare facilities. They produce biomedical waste, including used medical tools and infectious materials. If not properly segregated and disposed of, they can contaminate soil and spread diseases. These are not ordinary everyday trash. These are considered biomedical waste that not only contaminates soil when not disposed properly, but may also spread diseases affecting the entire ecosystem. From our homes to the crucial industries that make our world go round, our land is posed by threats caused by our very own actions. This section urges us to learn proper disposal and responsible use of our daily items. That would be it for my part. Let's have Mr. Sandoy for the next. Thank you.
Effects of land pollution into the human health, vegetation, and environment in general. The effects to human health are wide, and here are some common effects which are contaminated food and water cause poisoning and illness. Heavy metals lead to nerve and organ damage, respiratory and skin diseases from polluted dust. Long-term exposure can cause cancer. Pathogens from waste increase infection risk. These effects are triggered by the plants that get the nutrients from a contaminated soil and making them absorb heavy metals, lead or any risky element for human health. After that, people will eat that and probably they will cause any damage into the human health. The common effects to vegetation are toxic soil reduces fertility and crop yield due to not letting recover the yield after using chemicals. Contaminants stunt plant growth. They don't let the plant grow as normally. Plants absorb harmful chemicals, as mentioned before. Photosynthesis and nutrient uptake disrupted. The cycle of photosynthesis of the plants are not normal as it used to be. Sensitive plant species die off. Some plants cannot handle the chemicals from the land soil, so they die. Effects to the environment. Habitat destruction for animals and microbes, soil erosion and desertification, groundwater contamination, ecosystem and food chain imbalance, land becomes unproductive over time. These common effects are, for example, the lack of aviars, that eggs are not in proper nutrients, losing some quality and making the egg not be fully developed and easily to broke. Other things like microbes, important animals that will change their habitat will die. Application of waste management hierarchy. A framework of prioritizing waste management practices to achieve the best environment outcomes. Reduce, reuse, recycle, repair, recover, and dispose. The most important one is tier one and tier two, reduce and reuse. After that, there will be recycle. After that, repair, recover, and the last one, dispose. Dispose is the last option. The hierarchy is visualized as an inverted pyramid with the most preferred and environmentally friendly options at the top. The goal is to prioritize actions in order from top to bottom, only moving to a lower tier when the one above isn't possible. Top priorities: reduction, preventing waste before it's created, and reuse, using items multiple times, are the most effective strategies. They conserve the most resources, save energy, and prevent pollution by avoiding the need for manufacturing or disposal entirely. Tier 3, recycling, involves turning waste materials into new products. This reduces the need for virgin raw materials, save energy, and keeps usable materials out of landfills. However, it still requires energy for collection, sorting, and processing. So this means there will be soil problems too. They will affect the environment to make recycling material. Therefore, recovery involves converting non-recyclable waste into usable resources, primarily energy. This includes processes like incineration, waste to energy, anaerobic digestion, and capturing landfill gas to generate electricity of it. Again, this will produce contamination also. Disposal, the last resort, this primarily in landfill, is the least preferred option. It is reserved for waste that cannot be managed by any other method. Modern landfills are engineered to contain waste, but they still pose environmental risks such as methane emissions. Overall benefits of the hierarchies applying to the waste hierarchy provide significant environmental and economic benefits. It moves away from a linear take-make dispose model toward a circular economy that values resource conservation and efficiency. Thank you so much.
Okay, now let's move on to the control techniques for land pollution. The ways we can reduce and prevent further damage to our soil. First, we have proper waste management. This involves several key practices. We have segregating waste at the source, so separating the biodegradable, recyclable, and non-biodegradable materials right away helps ensure proper disposal and recovery of useful items. And we have composting organic waste. Instead of sending food scraps and yard waste to landfills, composting returns nutrients back to the soil and reduces the volume of waste we throw away. We also have recycling and reusing materials. This minimizes solid waste generation and conserves natural resources. Lastly, we have using sanitary landfills instead of open dumping. Sanitary landfills are designed with liners and leachate systems to prevent harmful chemicals from seeping into the soil and the groundwater. So, by practicing proper waste management, both at home and at the community level, we can significantly reduce land pollution and protect soil health. And so, another important approach is the reduction in the use of harmful chemicals. These include promoting organic farming, which helps reduce the reliance on chemical fertilizers and synthetic pesticides, which can degrade soil quality and harm living organisms in the soil. Next, we have the using biopesticides and biofertilizers, which supports soil fertility in a more natural and sustainable way while keeping ecosystems healthier. And we also have regulating industrial discharge of toxic chemicals and heavy metals, which is crucial to prevent contaminants from entering and accumulating in the soil. And by minimizing the introduction of harmful substances, we can help preserve soil biodiversity and ensure that the land remains productive and safe for future use. Next, we have land use planning and regulation, which focuses on designing and managing how land is used to prevent environmental damage. So, implementing zoning laws helps separate industrial zones from residential and agricultural areas, reducing the risk of pollution exposure to communities and farmlands. And we have conducting environmental impact assessments before big construction or mining projects, which ensures that potential harm to soil is identified and addressed early. And we have rehabilitation of mined or degraded lands, such as replacing topsoil and planting vegetation, which helps restore the land's structure, fertility, and ecological function. So, of course, proper planning and regulation ensure that development meets human needs while still protecting the soil and the environment. And next, of course, public awareness and policy enforcement, which plays a major role in controlling land pollution. So, environmental education and community cleanup programs encourage people to take part in keeping their surroundings clean and understand the importance of soil protection. Strict enforcement of waste disposal laws and pollution control regulations ensures that individuals, businesses, and industries comply with proper environmental practices. Lastly, encouraging corporate responsibility pushes companies to adopt a cleaner production methods and reduce waste at the source. With strong policies and an informed community working together, we can significantly reduce land pollution and protect our soil for future generations. And lastly, adopting sustainable practices is essential to maintaining soil health in the long term. So, of course, promoting the three R's: reduce, reuse, recycle, which helps minimize waste generation and lowers the demand for new materials. And supporting eco friendly packaging and circular economy models ensures that products and materials are used efficiently and kept in circulation rather than becoming waste. And of course, encouraging afforestation and reforestation helps restore degraded land, prevent soil erosion, and improve biodiversity. So, by integrating these sustainable approaches into daily life and industry, we protect our soil resources and promote a healthier environment for future generations. And so, all of these are ways that each one of us can help make a difference. So, from individual actions to large scale industrial efforts, together we can help reduce and mitigate the harmful effects of soil pollution in our environment. And that concludes our presentation. So, we hope you gained valuable knowledge and awareness from what we have shared today. Thank you, and let's continue working toward a cleaner and healthier environment.